Hello and good morning, everyone. This is Nathan, and I'm here to talk about incorporating various sentiment analysis techniques into recommender systems. So, before beginning, I thought I'd start off with an example which Martha and I were actually discussing during the start of our presentation. So, it's a hot summer day. What comes into our mind? Ice cream. So, I'm too lazy to go to the store. So I just go online and search for vanilla. So what comes up? Different types of vanilla ice cream, some with berries, sprinkles, and hot fudge on it. But then there's pistachio. Well, what's the problem with pistachio is there's actually a review about pistachio ice cream which states that the reviewer was an avid lover of vanilla, just like me. But after tasting pistachio, he's having a change of mind. Now he's become a lover of pistachio. And also, as you can see, 74 of 79 people actually agree with this review. So yes, this is actually but not a universal fact, but still a fact that vanilla lovers would actually love pistachio. So this here lies the problem. From a system point of view, recommending vanilla ice creams to a vanilla search query is actually highly accurate, but we could also incorporate pistachio to just a mild point, that saying that you would also like pistachio. You're not going to modify the entire thing, but just make a recommendation about pistachio. So how is this done is what we are going to be discussing later on. So okay, so the solution is just like I said, make use of the user generated content, because in the end the consumer is the one that buying that, not the system. So yeah, lot of data is available on the internet, be it in e-commerce websites or in travel websites, and review aggregators such as Yelp and various social media websites too. But there's also the limit of privacy which can be retrieved from data to make use of. So what are our implications we are looking at? Item re-ranking. Re-ranking the items so as to make more better recommendations and more personalized recommendations to users, and also enhance the user experience by encouraging content discovery for the users, and in the end, just like I said, better recommendations. So a brief outline about recommender systems and settlement analysis is a little needed. So first, recommender systems are essentially filters which a lot of data is available online. We don't want to host the user with all data we find available. We want to filter information to show the user the most relevant data that he would actually require. That's where recommender systems come in use. So there are three major types of recommender systems. One is collaborative filtering. Collaborative filtering is a statistical approach which takes into account the number of views, the number of purchase history, and in a sense user ratings too. And next comes the content-based filtering. Content-based filtering, it makes use of metadata from the product to get to know more about the product, such as the tags of the product or the category of the product, and also the user profile. The user profile where he might have liked a few pages relating to the product to make particular recommendations, or even the user has particular interest of a product which he has explicitly stated while signing up for the website. And then there's hybrid filtering, which makes use of both collaborative filtering and content-based filtering, while also some hybrid filtering approaches make use of some external information such as demographic and age groups. For example, kids would like toys and young teenagers would like video games and that sort of thing. And a major problem in recommender systems is the cold start. Cold start is where some items would just not pick up sales, or some items are just not viewed by users, so thereby it doesn't have any user generated content to move on about. So they would just be neglected by the recommender system. So hybrid recommender systems were actually designed to reduce the impact of cold start problem, but they were still not sufficient to address all the issues. So that's where sentiment analysis comes into place. So sentiment analysis, it makes use of various natural language processing techniques to extract numerous semantics from review data or any kind of textual information available through user generated content. It has a wide variety of uses which include topic identification, summarization, and feature extraction. So now these are the techniques we'll be discussing. The first three techniques are full-fledged recommender systems, whereas the last two are propose some novel ways to sentiment analysis. So first, the predictive model. So as you can see over here, there are two phases in the model which all the most recommender systems which I would be discussing would employ. The first phase is the sentiment analysis phase, and the second phase is the recommender phase. So just like I said, the cold start problem is addressed by sentiment analysis. So how you would ask is, over here in the predictive model, we actually predict ratings for products, predict ratings which would be given for products which have not yet been viewed by users here. So for example, I would buy a laptop from Dell, for example, and I actually write a review on my Dell laptop citing my preferences about the laptop, saying the battery was not good and the display was good, and more to the contextual information about laptops. So this can also be used to actually predict how a rating for another brand of laptop, say for example Sony laptops. So Sony laptops usually have better battery life but tend to have a lesser display resolution when compared to Dell, and also maybe lesser configuration for the graphics card or the processor. So based upon my review towards Dell, we can actually predict a rating and possibly even a review for Sony laptops. Now, how the predictive model, which was proposed by Zhang et al. And Pelea et al. Is they made use of the Multiword. The Multiword is basically a database which is an entire compilation of all sentiment related descriptors and keywords and their corresponding sentiment information, which contains subjectivity and polarity of the text. And the semantic orientation of words is determined through point-based mutual information. Well, semantic orientation, for example, I'd say I do not like this movie. From a natural language processing perspective, not and like are treated as different keywords. So, but if it would treat not as a different keyword and like as a different keyword, which would actually affect the polarity score in adverse manner. But if I make use of PMI, not like would actually mean a more negative manner than just like the distinct words not and like. So it is to determine the semantic orientation, we make use of PMI. And also, instead of using a linear classifier where we only classify objects as either negative or positive, we make use of multiple Bernoulli classifier, which goes on to a finer grained perspective of the review. So it goes on a scale of 1 to 10 and not just negative or positive. So the ratings are computed and they are incorporated into a set which contains numerous other parameters. These are then again incorporated into a user item rating matrix. So based upon this matrix space, we recommend users in the similar space with the same recommendations for other users in that particular space. So observations for the predictive model. Well, the predictive model entirely relies on the number of reviews. So the more reviews there are, the better recommendations we would receive. And then other thing about predictive model is that it doesn't go deeper into gaining aspects about the product. such as to know about, just like I said, the Dell battery thing. So it doesn't go deeper into the account of whether I would actually like something which would be of lower battery life, or if I would actually like something which would have high resolution. It only just computes that I do not like. It only actually processes that I say that Dell does not have good battery life, but it doesn't go on to process whether I would like something with good battery life, or what. It doesn't go to the personal perspective. It only goes to the perspective of what I had written. So how can we tackle this? The context-sensitive model, which was proposed by Leva et al., which is actually a very recent work and is to be cited later on more often, I guess. So the context-sensitive model, just like I said, it generates a user profile to know better the preferences of users. So it makes a number of assumptions. The first assumption is that users read reviews by critics in different manners. Different users read different reviews from a different point of view. For example, users, I myself am a very critical user. I tend to only read a review if it has some pros and cons just directly listed over there. So it makes use of this profile where I would actually only read pros and cons and not go into further detail about the product. So it bases upon how the user actually likes a review. And also, just like I said, PMI is also used over here to determine the semantic structure, and it goes on to explore the different aspects of a particular product. So in the Leva et al. Case, they made use of a hotel recommender system. So over here they process the purpose or intent of the stay in the hotel and the nationality of the particular user. I mean, for me, a national coming from India, I don't want to go back to India to look around. I mean, it's not like I hate India, but I've actually gone around to all places in India. I want to explore more. I want to go somewhere like Iceland or maybe Greenland. And the preferences. So, for example, I would like to go to a place where there's actually trekking available, and hiking. I would like to go hiking or spelunking maybe. So there's also the matter of preference. So it takes into account various factors. So, but the problem with this is that these are explicitly asked from the user through a questionnaire. That was what Leva et al. Proposed. But this is also, in a sense, a method of filtering. So it doesn't do much harm, but still explicitly asking user about such details may be not so intuitive. So as we can see, the weights are assigned to different categories and a net weight is determined, and then finally a virtual score for that particular commodity is determined. This score is again assigned to a user cluster matrix, and users in the similar clusters are made use of the similar ranks of recommendations. So yeah, here's a nice flowchart found in Leva et al. So yeah, just like I said, everything is over here. The user intent, nationality preferences, weights are assigned, and then we build a review score and then finally make the recommendation. So observations again. So the problem with the contextual information is that it requires a lot of grinding down to do for the contextual information. For example, over here we looked at nationality, purpose of stay, and the preference. For example, in e-commerce websites such as Amazon, they actually market a variety of products, I mean, I could even buy socks on Amazon. So if I want to buy socks, then I would like to my socks to be have a nice little pattern on my sock, or my sock would have to be in wool, or my sock has to be not too long to not as long as a stocking, but still I want it to be long, and also I want my sock to fit my legs perfectly, so the size matter comes into perspective. And again, we could revisit the laptop problem, where I go into the resolution, the processor, the graphics card. So yeah, it has a variety of contextual information we have to take into account for different products. And another good advantage of contextual information is that, in contrast to the predictive model, where we just dump in all the reviews and put out a virtual score, it actually works well in financially demanding situations, such as, for example, hotel or travel, where it actually requires a more better investment than just watching movies or videos online. Next is the latent aspect analysis. So this is essentially a topic identification model which makes use of the LDA, latent direct allocation. The latent direct allocation, well, I just quoted right out from Wikipedia. So yeah, it just assumes that each sentence actually has a particular topic. These topics are actually aspects corresponding to an entire document. So yeah, it's more topic identification, but more in a deeper sense than just generic topics and categories. So the HFT is the model proposed by Macaulay, and HFT stands for Hidden Factors as Topics. And the HFT, well, the HFT model was the most accurate so far, as proposed by Levi et al. They also make an assumption that the review parameter and the rating parameter given to the particular product are very much dependent upon one another, but these necessarily not be dependent. So they also predict a virtual rating, just like in the predictive model, and these are then compared with each other, and they also apply a transform to better predict a virtual rating, and then these are compared so as to they are not too varying from each other. So there you go. In context sensitive model, we did not make use of ratings, but here we make use of both the good of the predictive model and the context sensual model. So it also predicts a virtual rating, and it takes into account the various aspects in each phrase of our review. And it also helps in determining the helpfulness factor, just like in the ice cream pistachio model, where we found that 74 of 79 people agree with the review. So this helpfulness factor would also help in filtering out noise from noise reviews, such as spam reviews which don't even make sense. And one other assumption is that a helpful review, well, just like I said, how do we determine the helpful review? In a very helpful review, all the latent aspects relating to a particular product would actually be uniformly distributed and not just converge to a particular topic, and not just talking about that over and over again. That would be too repetitive. But yes, sometimes if you talk about something over and over again, you're actually trying to make a point over there. And observation, yeah, just like I said, this is actually the best model so far which I had studied, and it allows for a variety of other functions too. And finally, cold start, it's very good. It performs tremendously in case of cold start scenarios. And then from here on, we'll only be discussing about some sentiment analysis techniques which could be used in recommendation systems. So the tag-based model, well, over here so far we only deal with tags as keywords to particular products, but the tag-based model proposed by King Biao, I guess I'm saying it right.
Qing Biao.
Okay, so they also make use of the CentiWordNet database. So re-ranking is done by they actually perform a sentiment analysis on each tag so as to determine a polarity score for separate tags, and then different and then tags with similar polarity are re-ranked and they are grouped together to form a cluster. So over here it's a nice example found in the paper. So there are 3 animated movies, Sword in the Stone, Lion King and Chicken Run. And so as you can see, if I view it from a keyword pointer perspective, actually the first 2 movies have actually similar tags, but if I view it from a similar sentiment perspective, over here happy, funny and favorite actually have the similar sentiments. And over here the first 2 movies do not have any sentiments in particular. So to any person who watches the second movie, I would actually recommend the third movie and not exactly the first movie, because it does not have the similar sentiments of the tags. So here are some observations. So it entirely relies on the accuracy of the tags. So the metadata, the person who creates the metadata has to be very particular on how he creates the tags and not just generalize to a genre. For example, I could just say action for a number of movies which are not exactly action movies but also include maybe drama or romance. So, and also different people view different items with different tags. So just like I said, I could even say Lion King is actually a tragedy because the father king dies in the movie. So, but this was actually implemented by Steam, the gaming website. So yeah, this is actually a game, Dark Souls, which I have been playing too much recently. So over here we have user defined tags. I can define my own tags for the movie. So over here you can see a number of user defined tags which were created by other users. So dark fantasy, hardcore, masterpiece, yeah, a lot of very interesting tags over here. But there are also some tags which might not be very useful. For example, grossly incandescent. I don't know what that exactly implies, but that's not exactly very useful. I mean, I never saw anything grossly incandescent in the movie, in the game, sorry. So, and here is another aspect is multi-word terms. Well, so far for topic identification, we only treated it as either a single word term or a double word term. But according to Messenger, if we make use of multi-word terms for topic identification, it would actually improve the accuracy of recommendation systems. So the argument he makes is that if we make use of single word term, we actually abstract from the text and we don't go into a particular topic of the text. So for example, if I would say I'm talking about politics and I'm interested about the politics in India and how it's going on, or I want to know how the Indian National Congress is going on. So how the Indian National Congress fared in the 2014 elections, for example. So this is actually a multi-word term, Indian National Congress in 2014 elections. So there you have it. So I'm not just now talking about Indian National Congress in general. If I talk about Indian National Congress in general, it actually goes on to list me a number of other irrelevant items I'm not exactly interested in. For example, who founded the Indian National Congress, or what has been going on in the Indian National Congress, who is the leader of that particular party. But I want to know about a specific topic. So making use of multi-word terms for topics is actually proven to increase the accuracy of recommendation systems. So for topic identification, he makes use of a theme generator, which makes a set of semantic categories and multi-word terms and named entities. So observations, well, the problem with multi-word terms is that you can't exactly train a classifier or a machine learning technique for multi-word terms. This will actually result in underfitting of data. You are going on to too specific of a particular product, and you would end up with not actually fitting data that are at least a little bit relevant to the data. So it actually negates all other data. So this goes on to say that we actually require a lot of data to move on with multi-word terms. So if in case of data insufficiency, it would never work, and that's the case of cold start. So it actually intensifies the effect of cold start rather than reducing it. And one other use is that, for example, if we keep track of conversation, if two people are conversing about politics, they tend to talk about the same, well, Indian National Congress, for example. They tend to keep repeating about Indian National Congress. So if we keep track of conversations, we can actually infer from conversations about what two people are talking about over here. And we can finally interpret on what aspect in Indian National Congress they were talking about. Either were they talking about the present leadership, they were unsatisfied with the present leadership, or about the 2014 elections, for example. But this does not help in case of e-commerce, where I just write a single review. This does not help in identify a multi-word term. So yeah, that was actually what Mr. Rayal had done. He had used it in the comment is free forum, a forum where people just talk about politics over there, which is, I guess, well, some place you get to talk about whatever you get, talk about politics by the Guardian newspaper. So he keeps tracks of conversation, and he recommends user news about different conversations that goes on in the forum. So here's a nice summary about all the models so far discussed. So yeah, the performance, as you can see, the hidden HFT model in the latent aspects analysis actually works the best, and it also works good in the cold start. And as you can see, recommender systems, they don't make use of a universal standard for performance detection. They made use of different evaluation techniques. So questions?